The last pattern that I'm going to look at is a cubic. So again, a cubic should sound familiar to you. You've been studying it for a little bit, not as long as you've been studying quadratics. I need to recognize how to determine what a cubic is. But if you think about it, you've studied linear functions and equations. And we notice that the first difference would have been common. We just did quadratics. Again, you would have looked at that in terms of you've done that in functions and you've solved quadratic equations in algebra. And we looked there and we saw that the second difference is what's common in a quadratic. So maybe you might start to be leading towards what is going to show me that this is a cubic is that it should be the third difference is going to be common, and that's what's going to recognize it for me. So there's 8, there's 20, there's 38, 62 and 92. So not a common difference. So we've 12, 18, 24 and 30. Still, so it's not linear, not quadratic, but if we go for a third one, it is cubic. So third common difference. So third difference is common. So cubic. Could you generally tell me what a cubic looks like, that the ones that you've seen, or the longest ones that you've seen? So would be something like, so something x cubed plus something x squared plus something x, or minuses obviously, plus something. Now let's obviously, these all could be different things. So it might be ax cubed plus bx squared plus cx plus d, something like that. And because we're using the variable n in patterns, it's going to look something like this. So that's what the general term of a cubic might look like. Again, you might go to your log tables like you would have for linear and geometric, and this won't be there because, you know, you've been studying cubics for a while now. Same as quadratics, not for as long, but you have been studying it, so you should have a general idea as to what a general cubic should look like. So there's my pattern. I know if I want the general term, that it will eventually look something like this, maybe like a 2n cubed plus 6n squared, and it could just stop there. Or it could be an n cubed plus a 5n squared plus a 6n plus a 7. It could be that long as well. And obviously it could just be n cubed. We're going to have a look at the one here and see if we can figure out the general term for it. Now, if you look here, unfortunately, you have 4 things missing. So you automatically now need this hint. You don't need it, the hint above that I said for a quadratic, because you have enough algebra to be able to find 3 equations, 3 things missing, as we did back there. But you don't have the algebra to find 4 things missing. So you need this hint of where common difference, you need to divide it by 6, and that will be the coefficient of the n squared. So in this situation, 6 divided by 6 is 1. So in this situation only, that's a 1, because I got my third difference, that was common, divided it by 6, and I got a 1 here. Again, I can explain where this hint comes out of. perhaps after, you know, if you've done calculus or maybe another topic. But it's just a very helpful hint here in order to be able to know that's a 1. Once you know that is a 1, you are now left with 3 things missing once I start filling in that T1 in this situation is a 2. Anywhere I have a 1 or an n, I can put in a 1 and I can let the whole thing equal to 2. So we have a 1n squared plus, anywhere I have an n, I need to replace it with a 1. So 1 times 1 squared plus b times 1 cubed plus b times 1 squared plus c times 1 plus d is equal to 2. And now you should be able to see, right, b plus c plus d is equal to, bring this over, is equal to 1. Leaving cert simultaneous equation. I know that T2 is equal to 10. So anywhere I have an n squared, anywhere I have an n, I can replace it with 2. Anywhere I have an n, I can replace it with 2, yeah. Plus b times n squared plus c times n plus d, and that's equal to 10. Clean that up, you end up with 4b plus 2c plus d is equal to 10 minus the 2 cubed, gives me 2. And I also know that T3 is equal to 30. So that's 1 times 3 cubed plus b times 3 squared plus c times 3 plus d is equal to 30. Clean that up, that's 9b plus 3c plus d is equal to 3 when I clean it up and move it around. There's my third one. Should be able to go and solve that, figure out what b, c and d are. I already know a, and from there you should be able to come up with the general term. It'll be 1n squared plus something n, or 1n cubed plus something n squared plus something n plus something. When you solve your b, c and your d, you should be able to fill those in, and that's just basic, you know, your basic simultaneous equations leaving cert 1, so you should be able to figure that out. Once you have this, it allows you to get any part of the pattern that you want. This pattern here, a cubic, like a quadratic, because there's no formulas in your log tables, there is no fast way to sum up a cubic. You will just have to go to your calculator bit by bit, type in however many terms in the pattern they want you to sum up, and press equals on your calculator.